what does that SAT say? I think it says x, root 3, and 2x. You can literally use the x's, or you can give it numbers like we said. Now, most math teachers will say just go simple. 1 root 3 and 2. X root 3 and 2. 5 root 3 and 10. It doesn't matter. But most teachers will say go simple. 1 root 3 and 2. Okay? And once you have that triangle there, that reference triangle that we keep going back to, okay, it says go stand at 30 degrees. What is the tangent ratio? Opposite adjacent, right? So standing at 30, what's the opposite side? What's the adjacent side? So what's my ratio? Opposite over adjacent, right? So opposite over adjacent. That answer is good, but it's not simplified, is it? 1 over root 3, rationalize the denominator. We always rationalize the denominator, goes without saying. And again, if you see that, you don't need to show me that rationalization. It should be what? Root 3 over 3. Okay? That same thing is happening on those other groups, 13, 14, right there as well. Okay? All right, other questions? And that actually exact same thing happens on number 15 right below there. That's the exact same thing you're doing on number 15, right below that. Okay? Keep going. Other questions that you want to see from last night? This is your chance. Eric? Calculator. Can't type in cotangent, can you? But you can type in 1 over. And what's the reciprocal of cotangent? Tangent. So you can type in 1 over the tangent of 51, right? So remember, that's what you type into your calculator. So type in literally 1 over the tangent of 51, and then round it to what? The thousandths place, and then you're done. Okay? Yep, can't do the reciprocal functions in our calculator. TI does not build those into there. I think with the newest calculator out there, the Inspire, it has those built in. Who cares? We don't need it. So everybody else, we do the 1 over the tangent, 1 over the sine, or 1 over cosine for those. Okay? All right. So 1 over, what is it? We just said tangent of 51. So what is that to the nearest thousandth? Okay, it's 0.80. Now it's 9, and the 7 tells me to round the 9 up. So this one's going to be rounded to what? 0.810 in that regard. Right. Now again, you'll get a lot more comfortable next year in chemistry, because in chemistry you'll do a lot more rounding with decimals, I believe, in chem classes, and physics as well. Biology, not as much. All right, keep going. Other questions you guys want to check on? This is your time to keep asking. Okay, this is your time to keep asking. Go ahead, Alan. Sure. All right, number 3, standing there now. On this particular one, all right, this one is asking for, they give you some information here. It has, what is the angle of elevation here on this one? Now, from a tower, 60 feet above the water's edge, so they got that labeled for us already. The line of sight to a sailboat makes an 83.5 degree angle with the tower. So here, that line of sight I mentioned to you guys yesterday, what happens, the line of sight is the hypotenuse. So literally it's the line of sight right there. That's always the hypotenuse, right that. And the way that's phrased then is it creates me that angle right there with you. Now, the question here is asking, what is the angle of elevation? So in this instance, there's really no trig going on to this. It's more or less me asking you, from what we talked about yesterday, when I say what's the angle of elevation, you got to know that imaginary horizontal line that all of us have walking around. As you're just sitting there, Meadow's just sitting back there. Meadow has this imaginary horizontal line coming right out. We all do. Okay? So there you go. You know that, did you? Okay? Now, if Meadow turns the head up, we got this now angle of elevation going. We all do. And in this case, Meadow, you have a boat, right? Sailboat. Yeah. Dude, we all do, right? I wish. Mrs. Dresch, I keep asking you, let me get a pontoon boat. I don't want anything fancy, just pontoon boat. Just want to go out, set anchor, and enjoy the water. She won't let me, though. Then again, my little Toyota Prius probably will not pull a pontoon boat either, though. All right. So anyway, it's not going to pull it. It definitely won't. All right. So anyway, with that boat out there at the meadow, the angle of elevation, the ocean, the top of the water there, that's our imaginary horizontal line. So our angle of elevation to the top of that lighthouse, that is the angle of elevation right above that horizontal. So that is the angle we are talking about. Again, we assume for all these things to work that it's perpendicular to the ground, to the water level. And how many degrees in a triangle? 180, right? So 180 minus that 90, and then most importantly, minus that 83.5. So what is our angle of elevation? 6.5 degrees. That is my angle of elevation there. Okay. So that one really had nothing to do with trig. It's more vocabulary of knowing what do I mean by the angle of elevation off that. Now the 83.5, that's not an angle of depression. Okay. Don't get that confused with what we talked about yesterday. Now, Alex, my art critic, also happens to own a lighthouse, right? That would be nice. All right. The angle of depression, that is right here. That is my angle of depression right there. So those two are not one and the same. Meadows' boat right here is an angle of elevation. Alex, lighthouse critic, up here, when they lock eyes right here, they are at the same angle. They would also be at 6.5 degrees. They, the 6.5 with that 83.5, they will make a right angle. But 83 is not a angle depression. Don't think that's a depression. That 6.5 is Alex is standing up there critiquing Meadows' boat. Okay, because that's what she does. All right, we look down. There we go. Okay. All right. What else we got? Other questions you guys got? Keep going. Keep going. Any other questions you want to see? Go ahead, Adam. Six. These are the ones to start asking on. They wanted about angles of elevation, the good ones to talk about. All right. A woman looks down from a hot air balloon, sees a sheep below, and measures the angle of depression at 35 degrees. Now, how the hell does somebody on a hot air balloon measures with an angle of depression? Like, you should be like, how the heck does they even have it? Well, it's because you're in a hot air balloon, and what do you have to measure an angle of depression? What instrument are you using to measure an angle of depression? The sextant. We all have a sextant, right? No, we don't. So anyway, what a sextant is a measuring device. But you guys have all seen enough movies here, maybe the older movies, but that's what has been used before. Okay, so if you've seen movies back with our movies that are a little bit, a couple hundred years ago, all right, that you see on the old ships, those are measuring devices that are used to calculate the angles. Okay, so it's called a sextant. Those are being used to calculate the angles of elevation and depression. All right, so with that, for some reason, in this hot air balloon, that's what we've got going here, is a sextant. All right, so we got ourselves a hot air balloon, and this all again boils down to a right triangle, okay? So, hot air balloon's way up here, sheep is again kind of down here. Now, from here, all right, it's an angle depression. Angle depression off that hot air balloon is off that imaginary horizontal. So it's an angle depression was at what, 35 degrees? Okay. And that 35 degrees is outside that triangle right there, right directly below that horizontal. Now it says if the sheep is 125 feet from where the woman is looking down from the balloon, how high of the ground, off the ground, is the balloon? Here's the height of the balloon. That's going to be my variable. Now, where the 125 goes, okay? If the sheep is 125 feet from where the woman is looking down from the balloon, this is a little ambiguous. It can go, I would say, really kind of either place. I think it could be right wherever you put this, because again, it is kind of ambiguous of where that 125 goes. If the sheep is 125 feet from where the woman is looking down from the balloon, you could probably put it along the ground,
Or I think you could also put that along the hypotenuse, and I would not necessarily mark it wrong because it's not very clear, I think, to where you would put that at. All right. Now, most of the time, usually it's going to be phrased as you're going to probably put that along the leg. All right. But I think you could put that either way and make a case for that. Now, I'm going to bring that 35 degrees in because if that sheep looks up and sees that balloon, it's at the same measure. It's an angle of elevation from the sheep's perspective, and it's the same thing. Stand at the 35 degrees, and let's label that out. What's the X, bless you? What's the X represent? And what's the now 125 represent? And what do we have? Sine, cosine, or tangent? You will end up with just a lot of tangents. Bless you again. Tangent is what over what? Opposite over adjacent. Again, that's what I want to see. Solve for the variable. Calculator ready form. X is 125 times what? Tangent of 35. And go to our calculators, guys. And it says round to the nearest foot in this instance. So to nearest foot, 125, tangent of 35. It does tell us to round to nearest foot. In this instance, that's 80, not 7, but 88 feet. Okay, so this thing is about 88 feet off the ground. Okay, all right. Now we've moved past using whoever's audio can hear. Let's not listen to audio. All right, we moved past sextants, and we'll talk. Now this is all electronic, obviously. Okay, we moved past that. It's all digital, GPS, and all that. Okay. All right. Anything else anybody got that they want to talk about? I'm gonna do some more practice here in just a moment. 8, sure. Oh, okay. 8 right below that. Let's take a look at number 8. Draw a right triangle. All right, let's draw a right triangle. Check. Label the triangle with these 3 things. Now it says X degrees and 15 and 23 such that X is again an angle, and at the inverse of cosine, because that's the inverse, 5 over 23. We got to realize cosine, inverse cosine is representing the adjacent over hypotenuse, right? So 5 and 23 are going to represent side lengths, right? So wherever you want to put the X at, I don't care. It's an angle. I'm just going to throw it here. But now 5 and 23 have to go at specific locations. Cosine is, again, adjacent hypotenuse. Since I put the X there, 5 and 23 are locked in right there then. Okay? And now what do we want to do? What is the measure to the complement of X? All right, so what the heck does the measure to the complement? So let's think about that. What's it mean to be complement to X? What's the complement of, what's it mean to be a complement? What do we got? Sam? What's that you said? Yep, adds up to, you said, adds up to 90. So what we need to do then is figure out, first off, what X is using trig. And then after that, what adds up to 90, right? So actually what we want to do then is go right to using the inverse of cosine and find what X is. So the inverse of cosine, second sine of, what was the numbers? 5 over 23. So that angle that they start off with is 77 degrees. Now that we know that's 77, what's the complement to 77? 90 minus 77 is, what is that? Brain fart, 13? 13 degrees. Okay? So back to that vocabulary we've talked about throughout the school year. Okay? Good question on that one. That's a nice SAT question, the way that's phrased. It takes you that one extra step by asking that complement text. Good question. Anything else we got? Yes, ma'am. 5. Okay. Sketch it out. A tree casts a shadow that is 20 feet long. The angle of elevation of the sun is 29 degrees. How tall is the tree? Okay. So again, this all kind of boils down to just right triangles. Okay, as I was trying to say there. So as we talked about shadows in the last topic, shadows occur again along the ground, right? So that 20 feet is going to be along the ground. Shadows occur along the ground. How tall is the tree? All right. And where does an angle of elevation happen at? The elevation always occurs above the horizontal, right? And our ground is the horizontal. So right above that horizontal, above the ground, is my angle of elevation. So the sun's shadows sun's rays come casting down. And as they come casting down along the tree, that's where we get the shadow. And the angle of elevation is created right there. Okay? That's my picture. That's my picture. Stand at the 29. What do we got? Opposite, adjacent. Opposite and adjacent means tangent for the umpteenth time. X over 20. Alright. Now again, we expect you should be able to look at this. You got one of three ways to type this in. It's either it's going to be written as multiplication, division, or the inverse. You should be able to look at that and realize this can be written as multiplication. 20 times the tangent of 29. Go to your calculator. Doesn't say anything about rounding. It's a side length. So we write that as to nearest tenth. So this is about 11.1 feet tall. I think it's feet. 11.1 feet tall. Okay. All right. We're going to do a little bit more work today with angles of elevation depression. So make sure your name's on as always. And if you don't have it completely done, turn it in to me tomorrow. Okay. And throw it in the basket. Let's get those notes out. Let's do this one more time here today. Over a couple of things with that last quiz. Sketch it out. We've been doing angles of depression here. Let's talk about that depression here. We got kind of another thing going on here with mountain. Yesterday we did some rock climbing. All right. We found out yesterday, if you didn't realize it, Henley, you know Henley? He's a rock climber. I didn't know that. Okay. I didn't bet you guys didn't know that either. You guys know Henley? He's a rock climber. Interesting. All right. Let's do this. Did you know that, Sam? I didn't know that. It's surprising. I did not strike him as a rock climber. All right. So let's get going with this. Boy Scout on top of a 1,700-foot lonely mountain here spots a campsite. Let's go with our campsite here. It's going to be more of a house. All right. With the campsite. Now, at the top of that mountain there, that lonely mountain there, okay, we got ourselves this angle of depression. One more time, everybody's got this imaginary horizontal coming out of you. And as we've got that imaginary horizontal, that comes most importantly with an angle of depression. Okay, so sketch out that imaginary horizontal coming out of you. And then, what's it say? You spot that campsite. So create that now hypotenuse. You spot this campsite. Okay? As you spot that campsite now, you got this angle of depression just created then. Label that angle of depression. Alright. Where's that angle of depression going? Directly beneath that imaginary horizontal line that we all have. What's the angle of depression? It says 35. It's going right there, directly below that imaginary horizontal line that we all have. Now, what else do we have here? We have the height of the mountain, don't we? 1,700 feet. And we are going to assume for everything that we can do that this is a right triangle. Obviously, we're going to budget here to do that, but it boils down to a right triangle. Now, what else are we trying to figure out? How far is the campsite from the foot of this mountain? So that's going to be my variable. And you should be able to see our right triangle there. Now, if we're going camping, we're at the campsite. From our perspective, if we sight the Boy Scout at the top of that mountain, that's an angle of elevation, which is the same measure. We said yesterday those are alternate interior angles. And there we go. Stand at that campsite, give me that opposite adjacent hypotenuse. Standing at 35, 1,700 is a smooth. What is it? Holy crap, people! Just give me something. Yeah, that's what I'm telling you. 35 to 1700 is a. Thank you. X is a. Thank you. Sine, cosine, tangent. I know it's Wednesday. It sucks outside, but come on. Thank you. So tangent of the angle equals, what is it? 1700 over x.
Now again, that's my equation. After that, you should be able to tell me quickly how we set this up in calculator ready form. Multiplication, division, or as the inverse. Sam?
I thought depression was like down and like, so where your guy is,
Mm-hmm.
if you go down just like a little bit.
This
Yeah,
one?
that's where I have my 35.
Don't.
What's
It's an angle of elevations of pressure, remember? Always directly above or below that horizontal line. You said that 35 is here. Is it off of a horizontal line? No. This is off the horizontal line. So it's got to be off of that horizontal line right there. So this angle here, it's nothing. It's neither classification. Okay. So one more time, putting this in calculator form, multiplication, division, or the inverse. You should be able to tell me and look at that. X is in the denominator. So it's going to be as division. If you're not seeing that, what did you do all last week? You should be able to tell me that and go boom right to that. Now go to your calculator. 1700. Does it say anything word around it? Does it say anything about rounding? Nope, it does not. So it's a side length. And what's my default for side lengths? Nearest tenth. So 2,427 point, what was it?
9.
Thank you. Feet. Okay. That's it. Depression is the one that's typically most missed, by as Sam was pointing out. Putting that 35 right here, we do not. It's right below that horizontal that everybody has there. Okay. All right, let's go with one more here. All right, let's go with the forest ranger. Nice SAT question. All right, let's take a look at this forest ranger. This is a way that we can go about measuring those tall trees. Okay, using, like I was showing you a second ago, using our device that is like a sextant. All right, we have a little bit more fancier devices. What is that called? I'll come to it. Think about it in a second. That they use on road construction crews as you go past a road engineer. You see that tripod-looking thing, and they're looking through that device. They're measuring the gradient of the road. I can't think of it for the life of me at the moment. I'll think about it in a second. Anyway, this is another way you can measure the height of a tree without climbing to the top of it. Let's figure out the height of this tree here. Now, first thing I notice is all these answer choices, they are darn near close. So you don't want to necessarily do any rounding until the very end. Let's figure out the height of this tree. Forest ranger wants to determine the height of this redwood, standing 145 meters away from the tree. The ranger measures the angles of inclination and declination. So angles of elevation and angles of depression. Same thing, inclination, declination. All right. What we want to do then is, again, find the height of this tree. All right. So what we've got then is angle of depression. There's my imaginary horizontal of that forest ranger standing there. That's my declination. That's my inclination. All right. Now, we've got everything. That 145 meters, that is this length right there. We just need to break it down into two separate right triangles, and then what are we going to do with those? Add them together. That is the big height of the treetop. We just got to break it down to two smaller heights and then sum them together. You realize that. So let's go ahead and find the top one, that big angle, or that big Y. So standing at 17 degrees, the angle of elevation of inclination there. Standing at 17, what's the Y represent? Opposite adjacent hypotenuse. And what's this 145 represent? Yep, adjacent. Opposite and adjacent gives me sine, cosine, tangent. Oh my gosh, imagine that. Tangent of 17 equals opposite over adjacent. Okay, how are we going to write this up? Multiplication, division, or the inverse? I'm sorry? Multiplication. 145 times the tangent of 17, but don't go to your calculator. Pause. Because if we go to our calculator and write down a rounded answer, there's a solid chance we're going to get a rounded answer, add it with another rounded answer, but we're going to be far away from what probably the answer is going to be, because these answers are way too close together. So we're going to let our calculator put in these exact answers, let our calculator do the work for us, and then we'll look at rounding it all at once. Now, let's go do the x, okay? Standing at the 6 degrees, okay? Looks a little bit of an awkward one just because it is so kind of skinny, I guess. Standing here at 6, what's the x represent? 6 is my another opposite, yep. And what's the 145 to 6? Another adjacent. And opposite and adjacent gives me another tangent. Tangent of 6 is what to what? X over 145. And how do I write that up? Multiplication, division, or inverse? Look at your equation. X is going to be another multiplication, isn't it? Again, don't touch your calculator at the moment. That's where we're at. Okay? What we want to do here is add together whatever x is, whatever y is. So this is now what we're going to do with our calculator is plug in at the same time 145 tangent of 17 plus 145 tangent of 6. Do that. 145 tangent of 17. And this is where we talked at the very beginning last week. You better close that parenthesis. If you do not close that parenthesis, you're going to get a number that might sound okay, but it's definitely not going to be. So close that parenthesis and then immediately add it with 145 tangent of what? 6. By doing that all at once, your calculator can handle that, adding those together, and it is going to give you a much better answer than you typing those in, writing down a rounded answer, and then rounding the other one, and then adding those together. That's where we want to hold those answers until the very end. Let your calculator do the dirty work. Okay, based off that answer, where would you round that, and which answer would you choose? I would choose C as well. 59 point, what was it? 57. Based off our rounding skills, we would choose letter C. That is correct. Okay. Good SAT question right there. All right. All right. That's our trig. Okay. English validation, depression wraps it up. So I'm gonna pass back your trig from the other day, Monday I think it was. Give me a second there. We're gonna talk about that. Now I will say on this mini quiz from the other day, when I graded these, that on the first part, if you remember, what I graded was, or I gave you, the first 4 questions were some special right triangles. Now, I graded them, but I not count against it because this is a trig quiz. I want to focus more on the trig. I gave those special rights to you just to kind of keep them in your toes. So I graded them, but I not count with you or against or anything like that. But I did see some nice improvements already from that previous quiz. So that was good to see already. All right, I want to talk about the trig stuff here with you, so give me a minute to call your name, come up and grab this. All right, when I call your name, come grab it so we can talk about some of these. Grace, come on down, Grace. Myra. Sam. William. Now, it's a mini quiz, it's not going to make or break you, but I want to see some improvements by Friday's last quiz. I forgot to say the name. Ayla. Max. And most importantly, I want to see it by Tuesday. Tuesday's test. Right? Next. Ray.
Lydia's not here yet. That's socialized class. Eric. Helen. Parker. Blake. Nate. Harmony. Alex. Not that. Nope. All right. Let's take a look. Let's go through these really quick, guys. Talk about these. Give me a moment here. Alright, the other thing I want to do is look you up because I know some of you did just fine. I'm going to pass out the assignment for tonight in case you did just fine on it. You can start your homework too. For those of you that did not do or just made some silly mistakes, pay attention here once I pass out, once I go to the quiz. Just give me a moment. So as I said here, Friday is our last quiz. Usually with this mini quiz, some of you learn very quickly from the mistakes you made. That's fine. That's the idea of that mini quiz. It's not going to kill your grades. It's not going to make or break it. Even on Friday when we take the full quiz, it's not going to do anything to your grades at this point of the year. But Tuesday on the tests, that's where you need to make sure you pull it all together and do fine on that quiz. Sorry, on the test. You can always survive a bad quiz, but you can't survive a test. All right. So let me bring up the quiz here, go over that. Again, some of you did just fine. You can kind of tune me out like some of you always do. I get it. And then some of you definitely don't tune me out. Let me point out a few things here as we go over this. Okay. All right, real quick on the special rights. Like I told you, I already saw some nice improvements from that first quiz, so that was nice to see. On number 1 there, all right, it's my special rights. They ain't gonna go away. It's the 45. It's a hypotenuse. So what are we gonna do? We're gonna divide that by root 2, and unfortunately, we're gonna have to rationalize that. So as we do that, maybe not an obvious one to see about rationalizing that one, just going like that. So what I saw from several people, most people, is showing me that 8 root 6 over perfect square of 4, which is 2, and then reducing that down. 8 divided by 2 is 4, and you get 1, you get the second one, don't you? Because they are congruent. 4 root 6. Again, big improvement already from that first quiz, which is good to see. Letter B, it's a 30, 60, 90, and the nice thing about this one is you've got the short leg, don't you? 5 root 2 is my short leg. Taking it to the hypotenuse, we double that. So 5 root 2 doubled is 10, bless you, root 2. Taking it to the long leg, we take it times root 3. 5 root 2 times root 3 is 5 root 6, I believe. Again, big improvement off there. And then letter C. Again, we're getting much better. I would say we're about 90%. There's still about 10% of you that still refuse to do this Pythagorean theorem right. That's on you. 2 root 2 squared. I'm going to keep doing this one with you. It's going to give you 8. That's going to give you 15. It's that 8 some of you refuse to do right. And what's that going to give you? A 7. The square root of 7 is, well, yep, that's a 7. And on that last one there, there's our shared side. 45 starts it off, and that, whoops, 9 root 2, 9 root 2, and we got to multiply that to the hypotenuse as root 2, 9 root 2 times, well, root 2, isn't it? 9 square root of 4, that's perfect, which gives me 18 is my shared side.
And the x happens to represent my hypotenuse. And some of you forgot to double it. 18 times 2 is correct. And as I told you, these are right or wrong. I can't give you really much partial credit at all off of these. So take a look what you did. Now, I did not count these against you. I was just going in to check to see how they did. Now, some of you were very close. Some of you left as an 18 instead of 36, so those are easy fixes. Be more cognizant by Friday, but most importantly, better have these fixed over the weekend by Tuesday. All right, down below, number 2. All right, on number 2, what messed up several people, you did not listen to me about the second column. What's the problem with the second column? What angle are you standing at? And some of you still stood at angle A. And then therefore, what did you miss on angle B? You missed all 3 of those. Pay attention to the details. First thing is, using Pythagorean theorem, this missing side turned out to be 12, or it's a 3, 4, 5 in disguise, isn't it? Okay, sine of A is what? Bless you. 4/5. Some of you, not some, a handful of you, did not reduce these down. 4/5, because what is 4/5? 16 over 20. Reduce all these down. Secant, if I want secant, I first got to have cosine. So cosine is what? 12 over 20, which then reduces down to 5/3, and then reciprocal, which is 5/3. If I want cotangent, first thing I have to have is what? Tangent, and tangent, then reciprocal. So tangent is 16 over 12, flip it, 12 over 16, and reduce that down to what? 3/4, I believe. Okay. Now go stand at angle B. A few of you did not go stand at angle B, and then you just lost 3 quick points there. Go stand at angle B. Cosine's pretty straightforward, but if you did not stand at angle B, you're done for. Cosine is what? 16 over 20, which reduces down to 4/5. Tangent, again, straightforward, 12/16. That reduces down to 3/4. And cosecant, if I want cosecant, what do I need first? Sine. And sine is what? 12 over 20. But I got to flip it. And flipping 20 over 12 then, which reduces down to 5/3. So see what you did there? Fix those. Those are the easy ones to fix, especially if you did not go move to angle B. Okay? Those are easy ones to fix. I'm going to run those through you again on Friday, and most importantly on Tuesday. Okay? Now, on the back side we go. Again, these are some of you for the easy ones to fix, especially on that top equation there. Okay? Now, what I'm looking for on those is what we've been doing. I try to emphasize to you then, starting yesterday and today. When we go stand at angle 40 there, what do we have? Opposite, wrong button. Opposite and, dang it, come on. Opposite and what? Hypotenuse. So what I am seeing right here is opposite, sorry, dang it, sine of 40 equals opposite over hypotenuse. If you do not have sine of 40 equals x over 18, you should have missed a point or half a point right there, depending on what you had. That's the equation. If you don't have that equation, it ain't right. Secondly, calculator ready form. That's where I kept asking you today. Multiplication, division, or the inverse. It's multiplication. Get x by itself. There is really kind of only one way to write these. Go ask another teacher. It's only one way to write these. Then go to your calculator, type it in. 18 sine of 40 is 11.6. Some of you rounded it to 12. You didn't round correctly. It's a side length. You better round that to 11.6. Watching my time here. Don't shut up shop yet. This one is going to be opposite adjacent, which is tangent. 14 over 16. Did you write up the inverse correctly? Some of you did not. Some of you wrote the inverse up in the equation part of things. And then the inverse of tangent is On this one, 41 degrees. Some of you wrote 41 degrees, but you rounded it to nearest 10th. You wrote everything to nearest 10th. That was only 2 of those. Angles go to nearest degree. So see what you wrote on those. Those are exactly what we expect from you. Okay. So some of you missed a lot of half points on that side. Those are easy fixes for next week. That's why I give you a mini quiz. These don't really do anything to your grade. Fix them by Friday. Okay. Because of our time, we'll do the other 2 tomorrow. We'll talk a little more. We have time. But most of you, I think, probably realize what you already did now at this point. Talk more tomorrow. Okay. Look at these. Look at the buddy. All right. Look at tonight. Learn from the mistakes. That's why we're here at school. We do everything already. We want to be here. Help each other out.